So without wasting much time, let us proceed with the session. Some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh, as you can see on the screen. I have 10 plus years of teaching experience, completed MTech from IIT BHU in 2010. I have written a couple of books on engineering ethics and power system. And my areas of expertise are power system, electrical machines, electromagnetic field theory, material science, and obviously engineering ethics. Let us start with the first problem. The first problem I am taking for DC machines, everybody, because we have to solve 11 problems. That will take a little bit of time. So if you know the solution, parallelly you can start the solution, and otherwise you can follow the discussion. He's saying there is a 4-pole DC machine having 100 armature conductors. EMF induced in each armature conductor is 2 volts. When the speed is 1000 RPM, maximum allowed current in each armature conductor without overheating is 10 ampere. That is, current in each parallel path is going to be 10 ampere. The resistance of each conductor is given as 0.01 ohms, and the ratio of the armature copper losses for the lap and wave winding he is asking in the question. And today's class topic is that we are going to solve 11 important questions for your subject electrical machines. So basically he wants you to compare the losses in the lap and wave winding. So what you can do is, if there are 4 number of poles and suppose you have a lap winding, so definitely the number of parallel paths are going to be equal to number of poles, that is given as 4. So your actual armature winding is going to be looking something like this. And if you rewound this winding as a wave winding, you know for the wave winding the number of parallel paths are going to be 2. So your armature winding is going to be looking something like this. Now he is already mentioning in the problem that is the maximum allowed current in each parallel path can be 10 ampere. Yes or no? Because if this is your winding for one parallel path, and he is saying the maximum allowed current in each turn. Now this is a turn. How you make a turn? If you have 2 conductors, these 2 conductors are going to make a turn. Yes or no? So whatever current is going to be flowing in this turn, that is the same current which is flowing in this parallel path. So for the lap winding, you can say in all these parallel paths, the current is going to be 10 amperes each, so that you can find what is the armature current in case of lap winding. Everybody tell me in the comment section, is it clear? Run it. First you listen. Similarly, for the wave winding also, in each parallel path, the maximum allowed current is going to be 10 ampere. So the armature current in case of wave winding is going to be how much? This is going to be 20 ampere. So you know what are the currents, armature currents in case of the lap and wave winding. So if you can relate the resistance, armature resistance in case of lap and wave winding, very easily you can relate the armature copper losses. Now if you see, in general, how we are writing the armature resistance? Armature resistance, how we are writing? Suppose this is your armature. I am simply writing the resistance, not the EMF. Suppose this is your armature winding. And suppose there are a number of parallel paths. So if total number of conductors are Z, what is going to be the number of conductors in one parallel path? That will be Z upon A. So if you want to know what is the resistance of one parallel path, simply what you can do, multiply with a small r, that is the resistance of one conductor. And if you know what is the resistance of one parallel path and you know how many such parallel paths are there, A. So you can write the armature resistance as 1 upon A R Z upon A. So you can write armature resistance as RZ upon A square. Now whether it is a lap winding or it is a wave winding, it is not going to change the individual conductor resistance and the total number of conductors. So you can say in general armature resistance is going to be inversely proportional to the square of the number of parallel paths. Yes, Swapan and Saurabh, you are right. Listen. So can I write RA lap upon RA wave as number of parallel paths in the wave winding, that is 2, and number of parallel paths for the lap winding, that is 4, and this is square. So this is going to be 1 upon 4. Now if you want to write the armature losses for the lap winding and armature losses for the wave winding, what is the current in lap winding? 40 amperes divided by what is the current in wave winding, that is 20 amperes. And what is the ratio of this armature resistance for the lap and wave winding? That is 1 by 4. Everything is okay? Have I done a mistake? Yes. Okay, I have to make the square of the current. I have to do the square of the current. So this is going to be 2 and this is going to be 4:4, and that is 1. Is it clear for everybody? So the ratio of the armature copper losses in case of the lap and wave winding is going to be 1:1. Now this question, if you have a little bit of common sense, then you can solve very easily. What is that? Suppose I give you a black box, and in this black box I give you some resistances. Now whatever way you are going to connect them, that may change either the voltage or the current, but the power loss is not going to be changed. Yes or no? For a given number of resistances, you cannot change the amount of power, whether it is a loss or it is a general power. That is going to be constant. The product of voltage and current is going to be constant. So if you have a little bit of common sense, very easily you can solve this question without even solving that it is going to be 1:1. Let us see the next question. Very beautiful question. He is saying 4-pole lap wound generator running at 900 rpm. The self inductance of the commutating coil is given, that is 153 into 10 to the power minus 6 Henry, and the armature current is given as 108 amperes. The number of commutator segments, they are given as 55, and the width of the brush is given as 1.74 commutator segments. He is asking what is the reactance voltage. You all know what is the reactance voltage? Yes, what is the reactance voltage? Yes, what is the reactance voltage? What is the reactance voltage? You know what is happening because of the armature reaction. Along your brush axis, some flux is present. Now, if this flux is going to link with the commutating coil, the coil which is undergoing commutation, this coil is going to have some self-inductance property, and because of this self-inductance property, this coil is going to induce some EMF, and the nature of this EMF is to oppose the reversal of current. Are you getting this? This voltage we are calling as reactance voltage, and this you can write as L di by dt, which you can write as L2IC upon commutation period. So he has given you the self inductance 153 10 to the power minus 6 The current in each parallel path is going to be armature current divided by the number of parallel paths. The armature current is given as 108 amperes. The number of parallel paths, because it is a 4-pole lap wound, so this is going to be equal to number of poles. So you can solve this, 27 amperes. So the current in each parallel path is going to be 27 amperes. But the question is how to find this commutation period. Now in this question we'll learn, yes, listen. How to find the commutation period if this kind of situation is given in the problem. The speed of the rotor is given as 900 rpm. So rotor speed 900 rpm, you can write that rotor is making 900 revolutions in 1 minute. Now what is happening? Let us understand. Suppose this is your rotor, this is your commutator segments connected to the rotor where armature windings are going to be connected. Yes or no? And suppose these are your poles. Suppose it is a 2-pole machine. This is north and this is south, and there you have the brushes. There you have the brushes. Now suppose you are standing here and you are observing the commutator segments. In one complete revolution, how much commutator segments you are going to observe? How much commutator segments are going to pass through you in one complete revolution? All the commutator segments. How many commutator segments are given? He is saying total 55 commutator segments are there. So you can say one revolution time is 1 upon 900 minute, or you can write 60 upon 900 seconds. In this one revolution, how many commutator segments you are observing? 55 segments are going to pass through in a time of 60 upon 900 seconds. What is going to be the time to pass through one commutator segment? That is going to be 60 upon 55 900. And you have to calculate the commutation period by using the commutator segment width, but you know that commutator segment width is very close to the width of the brush, because generally mica insulation width is assumed to be negligible or 0. It is very, very small. Listen, Anand, listen. So you can write 1.74 commutator segments as 60 upon 55 into 900 into 1.74. Just calculate this value and put it here as your commutation period, and you will get your reactance voltage. Is it clear for everybody? Tell me in the comment section. Are you able to follow this? And everybody who is joining me live in the session, do not forget to like this session and share and subscribe the session and the YouTube channel BYJU'S Exam Prep, so that you get more and more important sessions in your time, and other candidates are also going to be benefited. Yes, everybody? I'm not sure, but I think you must be getting somewhere around 3.915. Just check this value. I'm not sure. I don't have the reference answer for this. Sopan is saying it is 3.94. So I think we can go with B option. Yes, B option we can go. See the next question. The next question is talking about the compensating winding. You know, for the compensating winding ampere turns is going to be how much? It is pole arc upon pole pitch multiplied by ampere turns of the armature winding per pole. Now this ampere turns of the compensating winding you can write as IA, because armature current is going to be the current in the compensating winding, because compensating winding is connected in series with the armature winding. See, your formula is going to be applied when the other parameters are also given. Here, with the help of just speed, we are able to solve because he is giving the brush width in terms of the commutator segment. The moment you observe that he is giving the brush width or the commutator segment width something like that, then you can use this method. Otherwise, you use your formula. Are you getting that? That is also correct, but you don't know the values. So the ampere turns of the compensating winding you are going to write as current in each turn, that is armature current. Number of turns, if ZCW is the total number of conductors in the compensating winding, just divided by 2, that is going to be number of turns in the compensating winding, because 2 conductors are needed to make 1 turn. So if there are ZCW number of conductors in the compensating winding, then how many turns are going to be there? ZCW divided by 2. The pole arc and pole pitch ratio is already given in the question, that is 0.7. And the ampere turns of the armature winding per pole you can write as IAZ upon 2AP. So this armature current is going to be cancelled, 2 is going to be cancelled, and you can finally find the number of conductors in the compensating winding. Approximately you will be getting close to 6, so make it an integer, and 6 is going to be the correct answer. Yes, everybody? Are you able to follow this? Tell me in the comment section. We have to be a bit fast today because we have to complete the questions today itself. Yes, everyone? Is it clear? See the next question. The next question is saying there is a 440 volt, number of poles are not given, so you can take 4 number of poles. Take it 4 pole 25 kilowatt DC generator has a wave connected armature winding with this much conductors. The mean flux density in the air gap is given as 0.5 Webers per meter square on full load, and the radial air gap length is given as 0.3 centimeters. You know what is this radial gap length? This radial gap length is given for the gap length between the interpoles and the rotor periphery. Yes. What is happening? If you have a 4-pole machine like this, then you know how interpoles are going to be something like this. They are small and tapered poles so that they do not replace the main field poles, and they are also connected in series with the armature winding because they also have to neutralize the cross magnetizing effect of the armature reaction in the interpolar region. Are you getting this? So basically this length, this air gap length he is giving you as 0.3 centimeters. Now what he is asking is calculate the number of turns required on each interpole. Now if we talk about the compensating winding, you understand the basic function of a compensating winding is to compensate the cross magnetizing ampere turns of the armature flux. You can say cross magnetizing effect of the armature reaction in the polar region. Now if you see the compensating winding, because compensating winding you understand is being provided in the slots made on the pole shoe, so air gap is not going to be very significant in case of compensating winding. So the basic responsibility of compensating winding is to compensate the armature reaction. Yes, ampere turns of the armature winding per pole. But in case of interpoles winding are going to have two responsibilities. Along with compensating the cross magnetizing effect of the armature reaction in the interpolar region, they have to take care of or compensate the air gap reluctance between the interpoles and the rotor periphery. So if I write the equation of ampere turns for the interpoles, it is going to be ampere turns of the armature winding per pole plus ampere turns to compensate the radial air gap reluctance. Now you know that ampere turns is nothing but number of turns multiplied by current, and with the help of the ampere circuital law you know that N into I you can write as H into L. H you can write as B upon mu naught into L because it is air gap, so mu R is 1. So finally you can write if Ni is the number of turns in the interpole winding and the current is going to be Ia, ampere turns of the armature winding per pole is going to be IAZ upon 2AP plus ampere turns to compensate the radial air gap reluctance is going to be B upon mu naught into L. Everything is given, you just need to find the number of turns in the interpole winding. If I remember correctly, you must be getting 74 as the correct answer. Is it clear for everybody? Yes, everyone? Tell me in the comment section, are you able to follow this? I see candidates, a lot of candidates, they are not hitting the like button. Just quickly hit the like button. It is a kind of feedback for me that yes, you are able to follow me. Yes, everybody. Let us quickly go to the next question. He is saying there is a 100 kilowatt belt driven DC shunt generator running on full load at 300 rpm and 220 volt bus bar. Continue to run as a motor when the belt breaks, taking 10 kilowatt. What will be its speed? So basically he is asking about two operations, generator operation and the motor operation. Because it is a shunt machine, you know that E is directly proportional to phi into N. Because it is a shunt machine, so this flux is going to be terminal voltage divided by the shunt field resistance. Neither you are changing the terminal voltage nor you are changing the shunt field resistance. It means the shunt field current is going to be constant, or you can say in general, until and unless you change the supply voltage and the shunt field resistance, the shunt field current or the flux is going to remain as constant. So you can assume it to be constant. So you can write this EMF is directly proportional to the speed. So if I have to write the speed in case of motor and speed in case of generator, then you can write it as the back EMF in case of motor operation and the generated EMF in case of generator operation. How you are going to write the back EMF for the motor operation? Remember the source logic. What is the source in case of motor? In case of motor, what is the source? The source is supply. Supply is going to give you everything. What supply is going to give you in the armature circuit? Back EMF, voltage drop in the armature resistance and voltage drop in the brushes. So you are going to write back EMF as V minus IA for the motor. IA for the motor, RA minus BCD. BCD means brush contact drop. The generated EMF in case of generator, I think you apply the source logic. What is the source in case of a generator? The generator itself is a source. So generated EMF is going to give you the terminal voltage, voltage drop in the armature resistance and the voltage drop across the brushes. So the generated EMF you are going to write as V plus IAG. This is going to be RA plus BCD. Now the only thing you have to remember is how to find the motor and generator currents. So that you can find here. For the generator operation, listen here. For the generator operation, the armature current is going to give you the shunt field current and the load current in case of generator. Whereas in case of motor operation, the line current is going to give you the armature current and the shunt field current. So first thing you have to solve is the shunt field current. The terminal voltage is mentioned, that is as 220 volts. And what is the shunt field resistance? it is 60 ohms. So this is going to be 220 divided by 60. Can you tell me what is the shunt field current? Yes, everyone. Now you can find the load current in case of generator. The rating is mentioned as 100 kilowatt and the voltage is given as 220. So you can find load current in case of generator also. Similarly, you can find the line current in case of motor. The power rating has become 10 kilowatt. So this is going to be 10 kilowatt divided by the voltage is given as 220. So if you have all these values, can you solve what is the armature current for the case of generator and motor? Yes or no? Everybody tell me in the comment section. Yes. 3.67 you are getting as the shunt field current. I hope this is what you are getting as 3 point. Swapan is the only candidate who is answering or solving the question. What about the load current for the generator? Can you tell me the value? Yes, everyone. Yes. Whenever you are coming for the problem practice sessions, you always solve the questions parallelly, then only it is going to be helpful for you. If you just listen it like any random video, then it is not going to help you. You have to do the practice. So just find these two values, the line current and the load current for the motor and generator case, and you will be getting the armature currents. Just put it here. Terminal voltage you know, armature resistance you know, 0.025, and brush contact drop is also mentioned, that is 2 volts. Yes or no? Can you solve this now? 0.025, terminal voltage is 220, and in case of generator the motor speed is given as 300 rpm. Is it clear for everybody? Sopan, okay. Other candidates also please confirm. Sopan is giving the load current for the case of generator 454.54. Okay, so you can find for the motor also. I think motor you just divided by 10, so you must be getting it as 45.45 ampere. Yes or no? Yes. So anybody solve? What is the answer we are getting? What is the speed in case of motor we are getting? Yes. It's okay, it's okay. So you can solve. What is the correct answer now? Let us see the next question. This is the last question from DC, then we will go for induction. He is saying find the number of poles from a 1200 kilowatt generator where the average voltage between the commutator segment is 15 volts. Now this statement you have to understand. What is the meaning of this statement? He is saying the armature ampere turns per pole is 10,000. So this you can directly write IAZ upon 2AP. This is given as 10,000. This is equation number 1. He is saying the generator has a single turn coil. What does it mean? Let us understand from the diagram. Suppose this is your commutator, and these are the commutator segments separated by the mica insulation. And he is saying it has single turn coil. What does it mean? Let us understand. What is the meaning of single turn coil? This is how the armature coils are connected in the commutator segments. And because it is saying it is a single turn, so see the single turn. Can you see the single turn? Yes. Now when he is saying the average voltage between two adjacent commutator segment is 15 volt, so you can understand this is the same voltage which is coming across single turn of the armature coil. Yes or no? So you are saying voltage per turn is going to be 15 volts. So if you want to write the total generated EMF in the generator, what it is going to be? If you can find what is the total EMF generated in one parallel path, so how many number of parallel paths are going to be there? If one parallel path EMF you can find, that will be the final EMF generated, yes or no? So if one turn you are getting 15 volts, can you tell me how many number of turns are going to be there? How many number of turns? Number of turns per parallel path. Can you tell me this value? Number of turns per parallel path. If total Z conductors are there, what is the total number of conductors? Z by 2 divided by number of parallel paths. This is going to be the number of turns in one parallel path. So Z upon 2A is going to be number of turns in one parallel path and multiplied by 15. This is going to be the total EMF. The armature current is going to be IA. So you can write the total power generated like this: Z upon 2A multiplied by 15 multiplied by IA, and this is equal to the power given, that is 1200 kilowatts. This is equation number 2. This is equation number 1. Two equations, two unknown you have to solve and you will get your answer. Two equations, two unknowns, and you will get your answer. Everybody tell me in the comment section. Yes, I hope you must be getting around 8 poles. Just check it. If I remember correctly, you must be getting number of poles as 8. Is it clear for everybody? Yes. Yes, Swapan. We will be getting 8. Let us go to the next question. He is saying there is a 3-phase 50 Hz induction motor runs at a speed of 576 RPM at full load. So full load speed is given. He is saying by what factor the rotor resistance be increased for the motor to run at a speed of 528 RPM, again at the full load torque. So both the speed condition he is mentioning the full load torque, it means the torque is going to be same for both the conditions. Torque is going to be same for both the conditions. How you are writing the torque? The torque of the induction motor you are writing as 3 E2 naught square upon 2 pi ns upon 60, and this is S R2 upon R2 square plus S x2 naught whole square. In general, slip is going to be a very small value. So you can write R2 square is going to be a much higher value in comparison to S x2 naught whole square. So you can ignore S x2 naught whole square and you can simply write the torque as 3 times E2 naught square 2 pi ns upon 60, and this is going to be slip times R2 upon R2 square. So this R2 is going to be cancelled, or simply you can write torque is directly proportional to slip upon rotor resistance. Is it clear? If the supply voltage is going to be constant, this is also going to be constant, and if the frequency of the supply is not changed, then the synchronous speed is also not going to be changed. So you can say the torque is going to be directly proportional to the ratio of the slip and the rotor resistance. Now you please understand, if both the situation torques are going to be same, so you can write slip for the second case and the rotor resistance for the second case, and slip for the first case and rotor resistance for the first case, like this. Now he is asking R22 with respect to R21. Basically this is what he is asking. He is asking by what factor the rotor resistance has to be increased. By what factor the rotor resistance has to be increased. So basically he is asking the ratio of R22 upon R21, that is the rotor resistance for the second case with respect to the rotor resistance for the first case. If you want to find this ratio, then simply you can write, you have to find the ratio of slip for the second case and the slip for the first case. In order to find the slip, you know the speed for the first case, you know the speed for the first case. Speed for the first case you can write as NR1, that is given as 576 rpm. It is going to be 576 rpm, and rotor speed for the second case is going to be 528 rpm. 528 rpm. So very easily you can solve what is going to be the slip for both the cases. But the problem is, in this question he is not mentioning the number of poles, so you don't have the synchronous speed, because in order to find the synchronous speed you require 120 f upon p. Frequency is given as 50 Hz, but the number of poles are not mentioned. How to find the number of poles of the induction motor? Please understand that in case of induction motor, the rotor speed is just behind the synchronous speed. It means the difference between the synchronous speed and the full load rotor speed is not going to be very much. So we have to find what is the closest synchronous speed with respect to these two speeds, 576 and 528. So if you keep on putting number of values for the poles, let me take p is equal to 10. You can start with 2, 4, 6. It is always going to be even. So the synchronous speed you will be getting as 120. This is 50 divided by 10. So it is going to be 600 rpm. Hit and trial you have to do. So you can find the synchronous speed also. The moment you have synchronous speed, you can write the slip for the first case as 600 minus 576 divided by 600. And for the second case slip, it is going to be 600 minus 528 divided by 600. Just find it. I hope you must be getting the ratio as 3. Is it clear, everybody? Saurabh Verma is getting 3. Yes. Everybody just tell me in the comment section, are you able to follow this? See the next question. It is a similar question. Some details he is giving for the rotor, induction motor. Rotor of a 4-pole 50 Hz slip ring induction motor has a resistance. So rotor resistance per phase he is mentioning in the first case as 0.2 ohms per phase, and it is running at a speed of 1440 rpm at full load. He is saying calculate the external resistance per phase which must be added to lower the speed to 1300 rpm and torque being the same. So the second case speed is going to be 1300 rpm and torque he is saying is same. And again, listen, again, yes, torque is going to be same. So you are writing T2 is equal to T1. So simply you can write S2 upon R22 is equal to S1 upon R21. But the only thing you have to take care in this question is that he is asking the external resistance. So external resistance is going to be how much? The rotor resistance for the second case minus rotor resistance for the first case. Now the same procedure you have to do. Now very easily you can find the slip for the two cases also, because number of poles are mentioned. So synchronous speed is going to be 120 into 50. Number of poles are 4. So this is going to be 1500 rpm. For the first case, slip is going to be 1500 minus 1440 divided by 1500, and for the second case, slip is going to be 1500 minus 1300 divided by 1500. You can find the slip for both the cases, and you can relate what is going to be R22, and then you can find the external resistance as R22 minus R21. Is it clear for everybody? Yes, everyone, just tell me what is the correct answer you are getting. Yes, everybody. I hope you must be getting it 0.465 if you are solving. Tell me in the comment section. Why your responses are delayed? Are you getting the question or not? These type of questions every year or the alternate year you are getting. Can we go to the next question? Yes, 465. 0.465 you must be getting as the correct answer. Let us see the next question. Now this is very beautiful question. This is very beautiful question. Understand. He's saying the motor is operating at full load with a slip of 3% and the synchronous speed of 1800 rpm. Okay. It is driving a load whose load requirement is independent of the speed. Underline this statement. We'll understand what is the meaning of this. For some reason, the line voltage drops to 90% of the rated voltage. He is asking determine approximately by what percentage the motor is going to run hotter or cooler. Now you understand by very simple logic. I am not promoting dowry, but most of the machines. Okay, the comment box is capacitive. That is why you are getting a delay. So I think you can design a circuit. Yes. Anyways. Now you understand I am not promoting dowry, but most of the equipments generally which are given in the form of dowry, they have induction motor. Just to give you a sense of this question, the moment there is a low voltage supply, then what is the first thing you are going to observe? What is the first thing you are going to observe in your motor? If you are saying the supply voltage is low, so what is the first thing you are going to observe? The speed of the motor is going to be reduced. Yes or no? Even a layman can answer this question. It's not needed to be a graduate in the electrical engineering to answer this question. If you ask any household person, if the voltage drops, what is the first consequence you observe? The first consequence is the speed of the motor is reduced. The moment speed of the motor is reduced, you can say slip is increased. The gap or the difference between the rotor speed and the synchronous speed is going to be increased. If the slip is going to increase, what is going to happen? You know, the rotor copper losses are given as slip times air gap power. Now we have to understand what is air gap power. Air gap power you are writing as the torque developed multiplied by speed, that is 2 pi ns upon 60. Now when it says the load requirement is independent of the speed, so what is the load? The load is torque. It means torque is constant. When torque does not depend upon the speed, it means the torque is constant. So this torque is constant. Supply frequency is not changing, so you can say the synchronous speed is also going to be constant. So by using this relation, can we say that air gap power is going to be constant? Yes. The moment you say air gap power is constant and you say that the slip is increasing, so can I say the rotor copper losses are increasing? When the rotor copper losses are increasing, you know that rotor copper losses are going to be directly proportional to the heat. So when rotor copper loss is increasing, heat is going to be increasing. Heat increasing means temperature is increasing. Are you able to follow this? Are you able to follow this? So friends, all of you just say hi to the great Ankit Joshi sir, one of the gem of mathematics in India. Thank you so much, sir, for coming to this session. We all are obliged. Thank you so much. It's a delight to have you in the session, sir. Everybody just say hi to Ankit sir. So everybody just, are you getting the picture clear in your mind that if the voltage is reduced, then what are the sequence of events that you are going to see in your motor? Now understand that one thing we have cleared here, that the temperature is directly proportional to heat and heat is directly proportional to what? Rotor copper losses. And you know that rotor copper losses are slip times air gap power. Air gap power is constant, so you say rotor copper losses are directly proportional to slip. So can I say the temperature is going to be directly proportional to slip? Can I establish this? Can I establish this? Everybody tell me in the comment section. Yes or no? Now the only thing you have to do is the change in temperature you have to write as T2 minus T1 upon T1. Yes or no? T2 minus T1 upon T1. Now accordingly, if you can relate with the slip, or you can write it as T2 upon T1 minus 1. T2 by T1 you can write as slip in the second case and slip in the first case minus 1. Now you know that torque you are going to write as 3 times E2 naught square upon 2 pi ns upon 60, and this is going to be slip times rotor resistance upon R2 square Sx2 naught whole square. And again the same thing you are going to do if you ignore the Sx2 naught square. So finally you can write that torque is going to be directly proportional to E2 naught square, and you know E2 naught is going to be directly proportional to the supply voltage. Yes or no? So you can write it is going to be directly proportional to the square of the voltage slip R2. Now this is also going to be constant because frequency is not changed, and this is going to be R2 square. So this is going to be cancelled. Now this time rotor resistance is not changing, it is constant. So if torque is going to be same, so can you write slip is going to be inversely proportional to the square of the voltage if the torque is going to be constant? Yes, everybody. Oh, thank you so much, sir. It's your greatness, sir, that you are saying this. I am obliged. And lot of congratulations, Ranjit. Okay, so you are going to give the other candidates some guidance later on when you are going to join. After that you can guide other students also. That will be better. Yes, everybody. So can you tell me what is going to be the relation between the speed in the second case and the first case? This is going to be V1 upon V2, and this is going to be whole square. Voltage, he is saying, has become 90%, reduced to 90%. So V2 is going to be 0.9 V1. So this is going to be 1 upon 0.81. Yes or no? So can you put this value here? Yes or no? 0.81 minus 1. So just solve this and you will be getting your answer. If you are getting a negative value, then don't worry, because the voltage is reduced, so the speed is reduced. Let me check something I have done wrong. Just a moment. Some calculation I have done. Okay, we have to put this value, na? We have to put this value, 1 upon 0.81. Can you just solve this? It is not like this. Just this is going to be 1 upon 0.81 minus 1. Now you will be getting the correct answer. Yes. So approximately, I think you must be getting approximately 25% hotter. Anybody is getting the answer if you are solving? Ram Kumar is getting 0.234. So close to 25% you will be getting, because only approximate analysis you can do. Yes. Now see the next question. There is a 3-phase induction motor which is drawing 1000 kVA at a power factor of 0.8 lag. A synchronous condenser is connected in parallel to draw an additional 750 kVA at 0.6 power factor lead. What is the power factor of the total load supplied by the mains? So the situation is something like this. Suppose this is the situation. Okay. Now this is a 3-phase induction motor. You can say induction motor is working as a load, and here one synchronous condenser is added. Synchronous condenser is going to have some load also. Yes or no? So what synchronous condenser do? Synchronous condenser takes real power from the supply and supply lagging reactive power to the system, so that it improves the power factor. He is saying the induction motor is taking 1000 kVA and the power factor is 0.8 lag. The synchronous condenser, he is saying, is taking 750 kVA and the operating power factor is 0.6 lead. Okay. Obviously, it should be leading. This should be leading because it has to be overexcited. Yes or no? It has to be. Yes, Saurabh, it is 24% approximately, but as per the given options, we have to go with 25%. Now see what he is asking. He is asking what is the power factor for the supply coming from the mains. Now you understand this. You understand this. We are aware that what is going to be the real power and reactive power coming from the supply side, because we know the apparent power and the power factor for both the synchronous condenser and the induction motor. So very easily you know that this induction motor is going to have some real power and some reactive power being absorbed. Yes or no? So whatever real power is coming here, that is given to the induction motor, and the synchronous condenser. At the same time, whatever reactive power is coming from here, it is going to be supplied to the induction motor with the help of reactive power provided by the synchronous condenser, like this. So I am first interested in the reactive power. If you see what is the reactive power absorbed by the induction motor, it is going to be how much? It is going to be 1000 kVA. Okay, it is cos phi is 0.8. So what is sin phi? 0.6. So this is going to be 600 kVAr. What is the reactive power supplied by the synchronous condenser? That is 750 kVA. Cos phi is 0.6, so sin phi is 0.8. So this is going to be 0.8. If you solve this again, you will be getting 600 kVAr. If you put these two values in this equation, then you will find the reactive power which is coming from the supply is 0, because whatever is the requirement of the induction motor in terms of reactive power, that is being supplied by the synchronous condenser itself. It means this Q is going to be 0. Now what is the meaning of Q0? If you have a power triangle PQS and you are saying, sir, this Q is 0, approximately 0, then what happens? The moment Q is 0, it means this angle is going to be what? This angle is also going to be 0. When this angle is 0, what is the power factor? 1. Yes, Sopan, are you getting this, everybody? Tell me in the comment section. Yes, everybody, let us see the last question for today. It says there is a 300 kVA transformer having a 95% efficiency at full load and 0.8 power factor lagging, and 96% efficiency at half of the load and unity power factor. What is the maximum efficiency at unity power factor load? Yes. How you are going to write the maximum efficiency? Can you tell me? It is going to be the loading. Loading means current for which you are getting the maximum efficiency. Yes or no? You know that. This is going to be X, that is the loading in terms of the current for which you are getting the maximum efficiency. So this is going to be X S cos phi upon X S cos phi. Now at the maximum efficiency condition, the constant losses and variable losses, the core losses and copper losses are going to be same. So directly total losses you can write as 2 times the core losses. Yes, see, we are going to have many sessions, not just one session. We are coming up with the Mahamarathon sessions also. So it is not that some portion of the syllabus is left unattended. Sometimes it may happen that some questions, it happens in your examination also. When you are going for the gate examination, you don't know all the questions coming from which area. But because we are going to have number of sessions, so you don't worry about the coverage, because what I am giving extra weightage here, in the next session, extra weightage will be given to the other portions also. It is not that only DC and induction we are discussing, okay, because you understand the limitation. Are you getting this? So this is how you are writing the maximum efficiency. Now the first thing I have to find is, what is this loading? Because he is saying maximum efficiency at the unity power factor. So power factor is going to become as 1. And I also don't know what is the constant losses, that is the core losses. And this is the reason you identify the moment you read the question, that why he is giving you the efficiency values for 2 loading conditions. Because you need 2 equations to solve 2 unknowns. What are those 2 unknowns? Those 2 unknowns are the copper losses and the core losses. For example, how you are writing the efficiency? You are writing the efficiency at any load, x as xs cos phi upon xs cos phi constant losses x square full load copper losses. This is how you write the efficiency, and multiplied by 100. This x is x for maximum efficiency. Are you getting this? Maximum efficiency. Don't confuse it with that. Now in the first case he is saying 95% efficiency at full load. Full load means x becomes 1. Power factor 0.8. So 95% efficiency will become 0.95. X is going to become as 1. S is given as 300. It is kVA, so 300 into 10 to the power 3. Cos phi is given as 0.8. So you can write it as 300 10 to the power 3 into 0.8 core losses plus x is 1. So it is PCUFL. Say this is equation number 1. Similarly, you can write the efficiency for the second case. Efficiency for the second case you can write as, directly I am writing because equation I have just written. So this is going to be 96%. So 96% efficiency. What is the loading? Loading is half of the load. Half of the load means x becomes 1 by 2. S is 300 10 to the power 3. And it is again unity power factor. So this becomes 1 divided by 1 by 2. 300 10 to the power 3 into 1 plus PC plus x square. So 1 by 2 is square. And this is PCUFL. Again you get the second equation. So these two equations you have to solve to get the value of both the losses, that is the copper losses, full load copper losses, and the core losses. I am just giving you the reference value because we have limited time. So I am just giving you the values. You can just cross check it. The full load copper losses you must be getting as 8.51 kilowatts. Just confirm this value. And the core losses you will be getting as 4.12 kilowatt. Are you getting this? This is the reason he has given you. See, very soon we are going to plan that session. Because of some technical fault, that session could not happen. So it is being rescheduled. Okay. You will be getting information about that if you subscribe to the BYJU'S Exam Prep YouTube channel. You will be getting the information. Apart from that, you can just join my personal Telegram channel on BYJU'S Exam Prep. The channel name is Ashutosh Electrical by Ashutosh Sir. Okay. Yes, Saurabh, I am coming to you. So how you are getting the maximum efficiency condition? The maximum efficiency condition says PC is equal to PCU. What is PCU? X for maximum efficiency is square, and this is PCUFL, and this is PC. Both the values you have. So can you tell me what is the value of loading for which you are getting the maximum efficiency? Just calculate this, because this is going to be 4.12 kilowatt and PCUFL is 8.51. So this X value, I think you must be getting 0.696. So upon definitely we'll do questions on long transmission line also, don't worry. Each and every part we are going to cover in these sessions, and we are coming up with a very rigorous series of sessions in these last 45 days. Okay. All the subjects, not even just technical, technical, non-technical, every requirement we are going to taking care of. So you don't worry, just stay connected, enjoy the sessions and learn as much as you can. So now put the values here. It is 0.696, 300 10 to the power 3, unity power factor, so it is 1. It is 0.696, 300 10 to the power 3, 2 times 4 point PC is 4.12, 10 to the power 3. Just solve this value. I think you will be getting the answer as 96.2. 96.2%. Is it clear for everybody? Yes, definitely. I'll be sharing the PDF also. Don't worry. I'm just telling you that you can join my personal Telegram channel on BYJU'S Exam Prep, that is Electrical by Ashutosh Sir. If you search this name, you will see my photograph. You can join it. You will be getting all the PDFs and everything. So this is all from my side, friends. Thank you so much for joining me live in the discussion. I hope you enjoyed the session and you learned also a lot of things. If you have any query, you can comment in the comment section of this video. Later on also, when you are watching it recorded also, and we'll be coming up with more and more such sessions. And these sessions are going to be very helpful for your upcoming GATE 2022 examination. It has been our experience detailed application form. Saurabh, I will tell you separately. You ping me on Telegram channel, or personally you ping me on Telegram. I will help you. So friends, stay connected. It is going to be a great journey. Next 45 days, we are coming up with very wonderful sessions which are going to be very beneficial for you. You just make a balance between your self-study and the sessions or the schedules. Whatever is your strength and weak areas, you have to identify, and accordingly you have to put in efforts in these last days so that you get the best score. And all my best wishes for your success. Thank you so much. Take care of yourself. Thank you, everyone. Thank you. Take care.